We have some kind of hours of commitment that we have. So we're looking for some dedicated volunteers to help us support this, and also non-dedicated volunteers, who cannot really commit the number of hours per week. Let's say 3 hours, for example. They can do it as a extended volunteers. So we are actually looking for a lot of volunteers who can help us in many different angles. Let it be programs, organization of the programs and identifying the speakers or whatever, right? Number of areas that we are looking at for help. If anyone want to really, help in this good cause, you're welcome to reach out to us at testoper@testoper.com. Be happy to have you as a part of volunteer teams. End of the day, as you all know, we're running the show as by the volunteers for the volunteers. So as a non-profit, that's what we're trying to do. Appreciate your help, or if you have some contacts or anyone who are interested in volunteering on the tech community, please reach out to us. Be happy to work with you guys to give back to the community as much as we can. All right, that's 10:35. Over to you, Harsha. I think you should get started. I'll be there for sure, Harsha, till 11, and 11 o'clock I need to jump, and I'll let you to close the session. Okay, please go ahead.
Yeah, sure. Thanks. I'll share my screen. Let me know once you're able to see my screen.
Yes, we are.
OK, so good morning and welcome to this session. So today we are going to look at another type of machine learning, which will be an unsupervised machine learning clustering. Basically, Kmeans clustering is what we are going to see. We are going to see the intuition behind that. I'll explain the intuition behind this algorithm, and Saad will give an example and walk you through how it is being used. So before we get into the details, a quick recap of what we have seen so far. We had an intro session on machine learning, and we saw the different major types of machine learning, that is supervised and unsupervised. And after that, we spent some time on understanding the linear regression and the logistic regression, which will come under supervised learning. Supervised learning is when there is a relationship between a set of input variables and an output variable, or basically there is a categorization already present in the data. There are classes identified. So what you do is when you get a new set of inputs, you just try to identify the already known class to which it belongs to. Unsupervised learning, you don't have that. You try to make sense of the data. Clustering is a classic example. So we are going to look at that. OK, clustering, as I mentioned, it's an example for unsupervised learning. So what is unsupervised learning? It is segmenting a heterogeneous population into a number of homogeneous subgroups or clusters. Sounds like a technical term, but it's in simple terms. You have a lot of data points, like you have data which is going to be defined by various parameters, say, for example, x1, x2, x3, x4, or something like that. And what you do is you use the clustering mechanism to form groups of data, like you try to find clusters within which they have like similar properties. That is what you're trying to find. So what I'll go through the line again. Segmenting a heterogeneous population. When you're saying heterogeneous, it's not grouped or categorized. Heterogeneous population into a number of homogeneous subgroups. When you're saying homogeneous, it is like it has got similar characteristics. So this is basically clustering. Why unsupervised? Because it doesn't rely on a predefined class. So there is no dependent or independent variable. So we had seen in case of linear regression or logistic regression, we had y is equal to something. But in this case, you will not have that way. So you will have you'll not have a predefined class. You'll only have like parameters like x1, x2, x3, those things, and you try to make sense of the data. The data points are clustered based on self-similarity. This is that homogeneous subgroup which we are trying to form, and it's up to the user to attach meaning to those clusters. Once you see an example, I think you will understand this better. So when is it done? It is often done as a prelude before the major analysis is done. For example, in case of retail industry, you want to decide which promotion can be run. Okay, you're trying to find something out with a machine learning algorithm. But before we find that out, it would help if you can segment the consumers. So segmentation is done with clustering. So what you do is you segment the consumers, know the characteristics or the how they would respond to various promotion possibilities, and then decide on what promotion could be used. If required, instead of using like one size fits all type of promotion, you can also decide on what promotion can be applied for each segment. So to arrive at what are those segments, that those things are done with a clustering mechanism. We are going to look at K-means clustering. Today, it's one of the most commonly used clustering mechanisms. The term K actually refers to the number of clusters which we want out of that data. We'll look at how this is being used. I'll pause for now to take questions. Any questions about unsupervised learning or clustering?
If you just add a hyphen between the K and the means, it will be a little more clear to everybody.
Okay, I'll add that. In the next slide, I have an example. Maybe I'll go through that too. It'll become clearer. So this is something which anyone who's interested in astronomy might be very much aware of. See, this is something which scientists did long back, way back. If I remember it correctly, it's 12th century. What they did was, based on the luminosity and temperature of various stars, they formed like different. They plotted like which stars belong to which level of luminosity and temperature. And when they plotted this, they found that there is a cluster which can be formed. Like for example, this is the main sequence. These are red supergiants. These are red giants, blue giants, and white dwarfs. So this is an example for clustering. This is something which was done after. In this case, the parameters are luminosity and temperature. Of course, these are like only two variables which are taken, but you will have several variables based on which the clusters will be formed. But this is one example of clustering which was done quite some time back, and it is widely applied in case of like market segmentation or in retail industry. If you want to have targeted promotions, if you need to find few things out, it is widely applied. So is everyone clear about clustering? What is the definition? How it is done?
Can you explain how unsupervised learning is applied? Because that was not clear. Maybe it is coming in the further slides.
Okay, so what you do is, okay, I'll take this example itself. In this case, what is going to happen is you for the time being, you forget that you have these captions. OK, main sequence, white dwarfs, red giants, red super. For the time being, you forget that. What happens is you only get data points which are like this. Like you have one data point here, one here, one here, here. You only get these data points. Even if you look at it visually, OK, you just plot them, luminosity and temperature. You just plot them, the various stars which are giving you the temperature and luminosity combination, and you plot them visually. Can't you see there is grouping which can be formed?
Yeah, that part of it is understood.
Right.
I'm questioning where the two parameters of luminosity and temperature came from in an unsupervised learning algorithm.
That is the input set of information which we have.
So when
For
we say
example,
unsupervised, we are still saying we are giving you these parameters on which to base your graphing and then decide
do the
upon
clustering.
the clustering. Okay,
Yes.
so there
So,
is some input still, and that would be what are the parameters you have to apply to these
OK,
these data points. Is that right? And is
correct.
my
So
understanding right?
yes, you're correct. So
Okay.
I think based on your question, I'll explain this a bit more. When I say unsupervised, it doesn't mean that the inputs are not available at all. It is how you're using the input and what the inputs convey to you. In case of supervised learning, say for example, when we saw housing market, we said size of the apartment, say you have the location and few other parameters, means that this much is the price of the apartment. So that when you get a new set of apartment size, location, everything, you know what the price is going to be. This is the set of inputs which are provided for a supervised learning module. In this case, like we saw it as an example for linear regression. If you look at this set of inputs, you have a dependent variable, which is going to be the price of the house, what we would model it as Y. And you have a set of independent variables. There are several parameters like size of the apartment, location, etc. So this is how input is given to you for a supervised learning. You have a predefined class application, which is already done. But in case of unsupervised learning, all that you will get is temperature and luminosity for all these data points.
Okay, a follow-on question.
Yes.
When I am, as an astronomer, observing celestial bodies, and then I have thousands of properties which I'll be observing about these. Luminosity and temperature happen to be just two of them.
Yes.
If I just say don't give luminosity and temperature alone, I give maybe 20 different properties that I'm interested in, and then I say these are my observed bodies, and these are the characteristics that I've observed. Are there any algorithms that will actually say, okay, these are the two characteristics or three characteristics which significantly cluster them into groups?
Well, okay, I cannot straight away give a simple answer. So there is some amount of data analysis which is done before we get to clustering. So your question, the point you're asking should be covered in that. So if you look at if I've gone through the sequence. So what I have done is the first step is identify the relevant variables in the data set. And in some examples, which I don't know whether Saad's example has that, but in some of the examples which I have seen, what happens is you have like you have this one coming in, like you identify, you analyze the variables, you have an exploratory data analysis which you will do. In that you will conclude what is leading to, what might lead to cluster formation, what might not lead to cluster formation. For example, you will get a data with say consumer. If you want to segment a consumer, you get a consumer number, some way of identifying number 1, 2, 3, 4, some specific consumer number. That is not going to help you in clustering. But you can look at other things, like if you are mentioning for this consumer number, you have, this is the spend pattern, this is the monthly income, this is the number of visits he makes to the store, all these things. If you want a cluster, the last three parameters will gain more significance. So that is the first step you need to do when you're doing the cluster analysis. You need to analyze the parameters which are provided, conclude like what will help in clustering, what will not help in clustering.
Okay. See, I've heard of tools available on various AI platforms where things like you can take Twitter feeds that are coming from thousands and thousands of people. The Twitter feeds is coming, and then whatever algorithm is applied is able to actually classify those Twitter feeds and provide some meaningful information that can be used in a marketing way.
Yes.
So that sort of thing is there must be some algorithm that do that say, okay, let me take two parameters and then see if there is clustering and so on. Go iteratively through pairs of parameters and see which one of them are really give me some way of clustering this.
So we can
let me answer that question. So most of the time when you're making a model like this in production, you don't know what the ideal combination of variables is going to be that is going to give you the best, most pronounced clusters. So what most people would do is that they would have an algorithm, and this is not something that's difficult to make yourself, right? You can get this off the shelf as well. but you would get an algorithm that would run the clustering through every possible combination of all the different variables that you have. And then the output of that clustering would be some kind of measure of fitness of how well the clusters were formed. And then from that, you would take the best clusters, which include the most variables. So you don't necessarily have to go through a different ML model for that. You can just do this through programming.
Yes,
Yeah, yeah.
that's what I
Okay,
was talking.
I got my answer. I was just wondering if there is any particular name for those types of algorithms or
This is a
programs.
validation. This is a validation method. I think it's called grid validation. I'll confirm that to you.
Okay, thanks.
Okay, so any more questions? Okay, I'll take that as a no. So we are going to look at K-means clustering today. So as I mentioned, it is actually a way of finding a known number of clusters. How we'll arrive at the number of clusters, I'll come to that a bit later. So I'll take a simple example. These are the data points you have. The stars are the data points. I haven't mentioned any parameter, but assume that for now, the data is defined by two parameters, x1 and x2, and you plot these points. So what you do is when you get it in the data, the system, see, we are able to see it here, and it's very easy for us to, if you look at it as a graph, like we can clearly say that this is a cluster, this is a cluster, but it's going to be in data, which is going to come. So if you don't have the visual representation, the system will not know. So it has to form a clustering mechanism. And sometimes you will need more than, just visual representation for you to do the clustering, because here it's easy with two parameters. So what it does is, first thing is we need to arrive at the number of clusters we are looking at. I'll cover that portion a bit later after I've explained the algorithm, how it does. Say we are trying to form two clusters. That's an assumption. OK, so what we do is we start with what we call as seeds. OK, we place two seeds, random seeds. What we do is we define, when you're saying these points, we define them with x1 and x2, give them 2 points. And after we define them, we find which data points are the closest to which seed. For example, like this star will be closest to this seed. So mark that as green. OK, you do this for all the possible things. For every point, find which one is the closest, which seed is the closest, and just categorize them. When you do the categorization, you will know you will form two groups, here and here. OK, here and here. After you form these groups, what you do is, and when you form these groups, you're going to find this with the, there are several ways of doing, but for simplicity's sake, let's take the distance as the parameter, the Euclidean distance, which is the straight line distance between the data point and the seed. OK, with that, we find which one is the closest, and we form two groups. After you've formed the two groups, what you do is you calculate the centroid of each group. First point, you take initial random seeds for the number of clusters. That is, in this case, we have assumed two clusters. So we take two seeds, just position them, and for each of the data point that has been provided, find which is the closest seed in terms of, like here we have taken the linear distance, find the closest seed. And what you do is you split them into two groups. You've done this. What you do is, after you do this, you find the centroid for each of those clusters. When you find the centroid for each of those clusters, it's very simple. In a two-dimensional way of finding centroid, you just sum up all the x coordinates, x1 coordinates, take the average x1 coordinates and take the average x2 coordinates. You will get the centroid for this group. Same way for the other group too. You find the centroid for those groups which are formed. Take those centroids as the new seed. OK, and then run the nearest point algorithm, the method again, and regroup them. Once you find the new centroid and then look at finding the distance and splitting it, forming the two clusters we are looking at, there'll be change in some of the points. Like if you can see here, the centroid has moved towards this and here, and you can see that some of the red stars are becoming green and some green stars are becoming red. You do this again, and when you do this, you'll find new clusters which are formed. Once you have new clusters formed, what you do is you find the centroid for those clusters again, and then repeat this process till you reach a point where the clusters are not changing at all. So it slowly moves towards this, and then you get the cluster which you're looking at with the centroid marked here. This is how K-means clustering works. I'll pause here for questions. Any questions at this point? Is it very clear?
Yes, I think it is clear.
OK, so the same thing I have explained in terms of steps. Identify the relevant variables in the data set. OK, this is a point which we discussed. Identify the optimal number of clusters. I'll come to that point how we can find. Initiate with seeds equal to the number of clusters. Find the centroid for the formed clusters. When you do this, when I say formed clusters, it is based on the you need to categorize the data points and then see what is a which data point is closest to which seed. And when you do that, you find the clusters formed. Find the centroid for those formed clusters. Assume the centroids to be the new seeds and repeat the process till you reach a point where the clusters are not changing. That way you have the final set of clusters.
One question.
Yes.
You just picked 2 clusters as an example, right? It could be
yes.
n clusters.
Yes, it could be n clusters. I'll also tell you there is a mechanism called elbow function, which is used for finding the optimal number of clusters. I'll explain that shortly.
Okay.
Any more questions? OK, I'll take that as a no. And there was one question we mentioned that identify optimal number of clusters. How do we find what is optimal for a particular data point? We don't have much information, right? So what we do is, so what I'm basically saying is in this diagram, if you see there are classes like blue giants, red supergiants, red giants, main sequence and white dwarfs. So 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 clusters are formed. So how do we know whether it is 5? So what we need to do is we can use something called as elbow function. For elbow function, what we do is we first assume there is only one cluster. That is, you have this complete thing as one cluster. You take the centroid for all these things, OK, for this complete data point. And after you take the centroid, find the square of the distance, sum of the square of distance for each of these data points. When you have one cluster, your sum of square of distance is going to be the highest for this data, because it's here. We know that even if you look at it visually, there is a clear indication that you can form 2 clusters easily. If you have more distributed data, you know that the sum of squares, when you take it as squares of the distance, when you take for one cluster formation, it's going to be the highest for any data distribution, unless and until it is very, very close and you have only one cluster. So you find the sum of squared distance when you take one cluster. Do the same thing for 2 clusters, 3 clusters, 4 clusters. You keep going on. You will get your sum of square of distance to 0 only for number of clusters equal to the number of data points. That is logical, right? If you have if you say assume that this one is, I don't know how many stars are there, but assume that there are 25 stars. And if you want to form 25 clusters, each star becomes a cluster. So that is when you have the sum of square distance from the centroid of each cluster becoming 0. You don't want to have to that level because you wouldn't, that's not actually clustering. You don't have to do anything at all. So what do you think will be the optimal number of clusters is you find what is going to be the elbow of this function. Here in this case, when you plot all these things for different numbers of clusters, at one point you will find that you wouldn't see a big difference between the previous one and the new value which you are getting in terms of sum of square distances. So that is when you conclude that this is the optimal number of clusters you can go with. For example, in this case, there is a bigger dip from 4 to 5, but 5 to 6 is a very small dip. So you can take 5 as the optimal number of clusters which can be formed. Since it's representing an elbow, this is called as elbow function. This is how you arrive at the optimal number of clusters. Any questions till now?
You will have to seed with starting with 2 and then maybe 1, 2, 3, 4, 5,
Yes.
and then as the seeds increases, then you will get this elbow function plotted out. Okay,
Yes.
thanks.
It's not,
Why do you call it the
it's not-
centroid when it is a simple mean?
Yes.
Why the term centroid? Because it has a completely different connotation geometry, right?
See, centroid, you can for any graphical point is what as you rightly mentioned, it is going to be for any set of graphical points is going to be the mean of the x coordinates and y coordinates. So that is what we are using. I know we use centroid more in the triangle context, but the actual meaning of centroid is that. And
yeah, okay, thanks. That's fine. Just the point.
Yes, and another thing is here we don't have seeds. What we are doing is we are forming, one cluster. Okay, take the centroid of the single cluster, and then you have two clusters. That's how you do.
Okay.
Okay, so that was the intuition explanation for K-means clustering. With this, I'll hand it over to Saad for him to walk you through a practical example. Saad, I'll stop sharing.
Great, thanks, Harsha.
Harsha, just one question I have. So can you give probably a visibility, you and Shad, like how many more sessions we're going to have before we close on this?
I'll come to that. I thought we'll cover it in the last 5 minutes. Since you're leaving now, you want me to cover it now?
Yeah, that would be good because see, we haven't right now. What we are doing together is the basics of AI, right? So next year we are planning to have a extended masterclass on details, right? Hands-on workshops and things like that. So just want to make sure that we have that clarity among all of us in this session.
Okay, so I'll tell you what the plan is. This is something which Saad and I have discussed. So far what we have seen is supervised learning, 2 mechanisms, and we are talking about unsupervised learning this week. And if there's something left, something we need to discuss in detail, then we'll do it in the next session too. So maybe next to this session and the next session will be for unsupervised learning. After that, see, this is we have straight away gone into the algorithm because uh, that's a core, right? Machine learning, people would want to see algorithm, but if you see the real data mining or machine learning algorithms build up, the process is different. You do something called exploratory data analysis. The data which you get is not it's not something which you can straight away fit into an algorithm and get the results. So you need to do a lot of processing, pre-processing of data, sometimes extraction, transforming, and then pass it as input to algorithms for you to get the desired result. So there is something called as exploratory data analysis, and we would also want to talk about the general process which we need to follow for a model building. So that we are planning to cover after the unsupervised session is over. So that I guess will take two sessions. So what we would have covered by then is exploratory data analysis and 2 supervised learning mechanisms and 1 unsupervised learning mechanism. After this, we are planning to touch upon NLP. So the example which I think Partha gave for Twitter, which he said like thousands or millions of tweets which are being analyzed. That will come under the text mining, sentiment analysis maybe, because you mentioned that marketing could be done. He wants to know something about the tweets. So we'll cover the natural language processing part. That's a different area altogether for 2 sessions. So with that, we are planning to conclude the introduction for machine learning. So the idea is to introduce you to various major concepts. As you rightly pointed out, we are not doing a very detailed hand-holding session or something like that. We are, of course, walking through the code, but that's not the detail level which you would normally go to. That we'll cover in the next year's plan which you have. But for now, this is the plan.
Okay, and then in this, deep learning probably is going to be next year. Sorry if I'm
Yes, deep learning will be next year. See, first thing is we need to understand neural networks for us to understand deep learning.
yeah, that would be the next year topic. Okay.
And that has be more complex. Let this be digested first. After that, we'll move to deep learning.
Maybe the next year, what we can do is we can split this session into 2. The first session is whatever that you mentioned so far, kind of a recap, right? We can say basics, and then we can create something advanced, and maybe we can have 2 sessions of this based on the slot that we would agree on. But anyway, Shad and Harsha, in tomorrow's meeting, please join. Let's discuss on that a little bit to conclude on that. But otherwise, yeah, good. Thanks, Harsha. It's pretty clear now. And I trust everyone here also understands what exactly they're going to get for next four weeks before we close the session for the year.
Okay.
Awesome.
Kader, just 1 point, since you're here, there's something I wanted to ask the participants too. So there are 2 points. One, I would like to receive feedback, like what you feel is good, what you want to change, those things, so that if there's some change which we need to do for the future sessions, we can do that too. So please feel free to communicate to us. You can mail me at harsha.testoper@gmail.com. So you can send your points, and then we look at incorporating if we can do it within these future sessions. So that is 1 point. We are also thinking of a survey type of setup. I'll discuss with my team and then get back to you on this. That is 1 point. And second thing is, will it help if you form study groups? That's a question I have for the participants. Do you want to have an informal setup where you guys can get together and dwell a bit more on the topics which we are covering, so that you understand it more? Do you feel the need will be there? I'm asking the participants.
Yes, and but it requires a very, very focused problem to be taken up for solution. And
you're more like an example type of thing, right?
Yeah, the more substantial than a sample or an example. I mean, it should be more substantial than just an example. It should be sort of
real
production.
World.
Yeah, very real world and very much in the enterprise domain.
Okay. Well, a couple of things, right? Just want to clarify before we go off track, right? The study group, by definition, it is 4 or 5 people coming together and studying together, working together on whatever, right, that they think. But what you're talking about, Partha, to me is maybe a good place to say. We are planning next year a project, a couple of projects, to help the people with the career. We are planning one project, and then we are also planning another project to help with the learning. What are all the things that you need to do to move from point A to point B, right? Continuous learning. So we are planning to kind of start 2 projects, which would most of the time, which would be, I would say 60-70% AI ML based. And what you're talking about, Partha, a concrete example that we need to work on. If someone is interested to work on, then that's the place where we need to do. Okay.
Yeah, understood.
Perfect. Just want to make sure that the definitions are clear. We don't mess up different programs and different activities. So study group, what Harsha is saying is, guys, you remember, when we are kids, we just come together and sit together and study, and sometimes don't study, whatever, right? Have fun. So the study group concept within the Testoper is like that. We already have number of study groups that formed by the community people. They just come together, sit together, and learn together, right? Likewise, what Harsha is requesting is, if someone wants to really want to form a study group, take a lead, want to form a study group and study together, if you are interested, then reach out to Harsha. Right, Harsha? I suppose I made it clear now.
Yes, Kader, thanks.
Yeah.
Okay. Over to you, Sath.
Thanks. So for this exercise, we're going to be using primarily Scikit-Learn and Matplotlib. Rather than importing a data set, what I want to show you guys is a way that you can actually generate a randomized data set. Scikit-Learn has a function called make blobs, and you can use this to specify the numbers of centroids in a data set, set a standard deviation, and then generate it. And the default function that we see right now generates these points in 2D, but you can also you can generate points in n dimensions. Let me just show you how this is going to look. Sorry. Can you see the text?
Saad, there's a request to increase the font size.
Okay. Is that better? So as you can see, this is the make blobs function at work. We told the function to make 300 samples. The default is 2 dimensions. So you can see you have an X and a Y. Cluster standard deviation, essentially the higher this is, the more messy the data. So if I set this up at 0.7, for example, you can see that the clusters are less pronounced than they were when the standard deviation was less. If I make it even lower than before, you can see the clusters are more pronounced. So I'm going to keep this at 0.6. So this is the data that we're dealing with. Also, I'll just show you how it works in 3D as well. So again, this is a similar function with 1000 samples in 3D. Because it's hard to understand the data in 3D, I'm going to stick with the 2D example, but you can do this exercise in as many dimensions as you want. So we're dealing with this data right now, and what we want to do is we want to obviously create clusters, right? What we don't know is how many clusters are there. I can visually see right now and say that there are 4 clusters. It's very clear, but a lot of the times the data that we're dealing with is going to be in many different dimensions. So we can't ever say for sure how many clusters they're going to be, which is why we're going to use something called the elbow method. Let's put this data set through the elbow method and see what we get. So this is what you get in the elbow method. What the elbow method does, it shows us the, I think it's the sum of squared errors, I think. Is that right, Harsha? Can you just go over the logic of the elbow method really quickly? I don't know if you covered it in your presentation. Okay, no, never mind. I think he's away from his computer. So what the elbow method basically does is it tries to tell you what the optimal number of clusters are. So as you can see, when we reach 4 over here, the line sort of flattens out. What this tells me is that we should go for the 4 number of clusters, and you can see this whole line forms an like an arm, and 4 is the elbow. So in this experiment, we look for the elbow in the data, and whatever number of clusters the elbow is formed at is the number of clusters that we're going to aim for. Any questions about this? Okay, so what I'm going to do, this is the Kmeans formula in Scikit-learn. I'm going to put the number of clusters in using the elbow method that we decided on. So that's 4 clusters. We have 300 samples here, and we are going to run this. Now what we've plotted after we put it into after we ran this through Kmeans told us where the centroids are, and when we gave it 4 clusters, it's told us that these are the centers of the 4 clusters. Now let me just show you what happens if I put in an incorrect number of clusters. Right? Let's say I put in 3 clusters in the data. So here, when we put in 3 clusters, Kmeans is still going to try to find the centroids, and these are the 3 centers that it's found. So this sort of validates the output we got from the elbow method. 3 clusters is not a very good fit. We know that the right fit would be 4, right? Let me just try it with one more. Let's try with 5 clusters. Again, we both know these are all suboptimal, but just to experiment, we can see what the output is. Again, when we try to force in 5 clusters, it's separating these data points into 2 clusters. Again, this is not optimal. Again, shows us that the elbow method, the output it gave us, was the correct one. Right, so this is the correct output based on the elbow method. We've found the centroids on this data. Now let's get the exact value of these. So these are the exact value of the centroids. Now, the way this is indexed in Kmeans is that the first one is going to be 0, the second one's going to be 1, then 2, and then 3, right? So how do we use this kind of model? Using Kmeans.predict over here, whatever new set of variables I give to Kmeans, it's going to put them in a cluster, right? So I can give it a random type of combination here, and it's going to try to give it a index number for the cluster. So if it thinks that this fits in cluster 1 or 2, it's going to just output the cluster name. So before I run this, let's just visually try to figure out which cluster this would go with, and then we'll see the output. So this number is 0.9 and 4.5. So that would be here, and it would be this one here. Which cluster is it? This should be cluster 1. It's very similar to the centroid of cluster 1. Is this making sense to everyone right now, or do you want me to answer any questions?
No, I think it's clear.
Okay, great. The second combination that I will give Kmeans will be minus 1.5 and 8. Let me see which cluster that would fit into. Like, again, just visually validating it.
So even right now, you're actually selecting the parameters or the the points, right? What will actually happen in real life is you will get some data from outside, and that you will just feed into the model that has already been built, and it will tell you this.
Yeah. Up until this point, when you see this, the model has been built, right? This data that I'm putting into .predict, you can imagine this as data coming from outside. Okay. When I run, so these points this model hasn't seen before. The model's already built. What the model is now trying to do, whatever points come from outside, like these, it's going to try to put them in one of these two clusters, 0, 1, 2, 3. So the output of dot predict, or all the data that comes in from outside now to the new model, all it's going to do is it's going to try to put it in one of the clusters.
Yeah, got it.
Okay, so let me run this here. So the first points I gave it, it put it in cluster 1. And the second points that I give it, it put it in cluster 2. So you can see over here, cluster 2 is minus 1.3 and 7. So minus 1.3 here and 7. This is going to be cluster 2. And you can see that the point I gave it, minus 1.5 and 8, fits in over here. So you could give it any sort of set of new points, and you could do this in as many dimensions as you want, and it would be able to assign them different clusters. Any more questions on this? Or any of this code? Okay, so that completes this example. We have about 10 minutes left. Harsha, are you still online? Okay, since Harsha isn't here, do you guys have any questions for me? If not, we'll then close this session. Do you have anything regarding the code or any question regarding the concept of Kmeans clustering?
Hey, Sad, there's some mic problem. I'm
Sure.
online. Tell me.
Sure, yeah. So do you have anything to add before we close the session? My example is complete.
Yeah, this is fine. Maybe next session we'll go through the complete thing with some example data set. You want to see it again, or will this close the clustering session?
It's always useful if we get the context in which this will be used in real life. And yeah, so that's you know, we are looking at mathematical points and you know, numbers, but basically if I understand it correctly, what will happen is we will get some let's say we get a new customer, and we want to classify this customer. We don't know his age or this, but just by his the pattern of what he's searching for on a retail website, will probably be able to place him in an age group cluster. Is that a good example of that?
That becomes supervised learning, right? Because what you're doing is you have like you already have clusters formed, and then what you do is you have classes which are formed, and when you get a new set of consumers, you try to classify them in those classes. So that becomes supervised learning. This is when you're trying to segment without that information.
What I'm saying is this will be this model that has been built will be used in that way.
No, what you will do is you will have a model. You segment the data points which are there. So you have different groups. After that, what you do with the groups is in your hands. This is not used for like when a new guy comes, whether to assign him to a particular cluster or not. That becomes supervised learning. This is unsupervised learning. So what you do is simple thing is, as when I mentioned about a promotion in a retail setup, like you need to target different segments of people with different promotions for your promotion to be effective. Is that correct?
Yeah, that would be an objective. Okay.
That would be an objective. So your business problem is I need to design the promotions for my customers. Okay. First question, do you decide on one promotion for all segments of customers, or do you want to decide different promotions for different segments of customers? Do you have different segments of customers first? So when you have that first question, like I'm designing what is the promotion I can design for my customers, there is a sub question which gets formed. Is it like one size fits all, or do you want to look at different segments and then do different promotions? Okay, and then another sub question from there. What are the segments which are there? When you have the question, what are the segments of customers you have? You use a clustering to find out what are the different segments. That is where this one will come in. I just gave an example.
Thank you.
Yeah, one other very popular example is when scientists study, for example, butterflies, right? Let's say you have two different colors of butterflies, but you just have a lot of data on other characteristics of different butterflies. You put them into a K-means model, and what you might see there is you can get two clusters, and that will allow you to sort of see this hidden class of color for those butterflies as well. So you can then use K-means to separate out red and blue butterflies, for example. So that's actually a real life data set as well. Maybe we can go through that at a later class, where you actually have the characteristics of these butterflies, and then you can see that two clusters are formed when you apply K-means clustering, and those clusters actually have the different colors of the butterflies. So that's actually a real data set. We can actually bring that in one of the next classes as well and discuss it. Okay, should we then close this session?
Yes. So what we will do is maybe in the next session, we'll look at something like a real world example to help you understand more on the clustering. And we'll also go through like how it is done in the code. Sad, will that be okay?
Yeah, definitely.
Okay, we'll do that. So we'll continue with the clustering in the next session before we move to exploratory data analysis.
Okay, great.
Thanks, Sadin, Harsha.
Yeah.
Thank you.
Okay. Thank you.